All right, so good morning, everyone. I'm glad we're off with front-end boring stuff, and we're like back-end Node.js, you know. So, hi, everyone. My name is Liran. I'm an engineering manager at Nielsen, where I help build a marketing cloud platform. It's mostly JavaScript and Node.js. I came from Israel, and it's in the Middle East, and we commute to work like this on camels. So it's worse than your traffic here, trust me. And that's in the morning, so we don't have a lot of traffic, and it still took me like an hour to get to work. Middle East, what can you do? Actually, this is Tel Aviv, so it's pretty fun and fast-paced, like was said here a couple of times on the industry. And what I'm really passionate about is open source. When I'm not doing the all coding hours at work, being a manager is kind of taking you into meetings and a lot of other stuff that we were singing about in the morning with the TBDs. So I'm doing it at home and some at work as well. But I had a privilege for the last 2.5 years to lead and maintain the Mean.js project, which is my very favorite mean stack. And recently, actually, I also had a privilege of taking care of some of volunteering activity around OWASP, which is an activism volunteering community around security. For web applications, part of which we'll actually touch today. There's a Node.js project called NodeGoat. We will use it today. It's by design vulnerable, so we can do an educational experience and see how many security vulnerabilities we can go when we are doing Node development. So beyond that, at home, this is my kid, Ori. He's 3 years old. And yeah, you can do, oh. Yeah. Thank you. As you can see, we take security pretty seriously. We had a session on, I don't know if you can read it, the CSRF tokens implementation for Node.js. And he really got all of it. I only paid him like $100 to laugh when I took a picture. So it wasn't that pricey to go to the conference and have the picture. But we actually do take it seriously. And if there's something I want to convey to you in the talk today, is basically to give you a focus of a mindset for security, where when you will write code or you would code review things for your colleagues, you would have that red flags coming up for security. So if you see something fishy, you're gonna cut it. So there's going to be a lot of security, obviously related stuff, but a lot of it is tips and tricks which are very practical. So going back to what they call the magical 2010, and people have been talking about it for a while here in some of the talks. This is where I think really JavaScript started its rise with all of these frameworks. Maybe most notably, I really remember and like the 2010 because we had Justin Bieber winning the American Music Awards, I think. But maybe Node.js, I think, has been really contributing to this rise because it had all of this ecosystem and all of these tools, and the NPM repository has grown so much. So it made JavaScript really go everywhere, and we've also touching this throughout the talks today, whether it's IoT and universal apps and server-side rendering. So everything is today JavaScript, and JavaScript is really everywhere. So this is why I want to talk to you about some security horror stories that I've just been noticing around when I was working on this tech. My fail number 1 that I want to share with you. By a show of hand, who has heard about this package called rimrafall? Awesome. So not a lot, but it's good that some people know. So rimrafall is a package that has been sent to the NPM repository a couple of years ago, as you can see. It's very special. I really recommend it. I'll let it speak for itself. It has a pre-install script that runs rm-rf/*. When you install it, it's going to run. So if you want just to render your system completely useless, install this one. It was actually really, the open source repository for this actually is still alive. And of course, there's a disclaimer that take it on your own risk. But it was published as a test experiment to NPM. And it showed how much this ecosystem is very open, but also very vulnerable if we don't know what we're doing. So it was there for a while, like about 2 hours after it was taken off. And this was on Twitter back then. So everyone was letting NPM.js know, and they took it down. But this is something that if people actually installed through, I don't know, Reddit or Hacker News or whatever, it could harm their system. And it did. So fail number 2. Validator.js, it's a library that we'll talk about today a little bit more in depth. But let's say that you want to use it to sanitize your strings. You're like, after this talk, you're going home, working on your laptop, and maybe you say, I want to do Validator.js. It's running pretty fast. Let's do Validator.js install for my project because I want to validate strings the right way. And you see the repo is also called Validator.js. So the next thing you will probably do is go to your terminal and do npm install Validator.js. Makes sense. Except the npm library actually called Validator, not Validator.js. Right? So this is kind of a phishing attack where you can have malicious modules in a similar name, where just a typo away could actually harm your system if it had a pre-install hook. I'll give the example for Socket.io, since we have Guillermo in the crowd. So many downloads for the real one, and not so much for the one without the dot. And it doesn't mean that it's malicious or not, but it just shows that people can install it, and just by accident, or just a typo or a wrong copy and paste, could install something else. So that happens. Fail number 3 is this tutorial I was seeing on the internet. Seemed interesting. Node.js, reactive, Wi-Fi dashboard, stuff I like. I'll try to read it. So really innocent reader going into this. And when I was looking through the code, having this security mindset something was popping up at first. If you will take a closer look, like I did, you will actually have your mind pay attention to what's going on there with the child process exec, which is executing commands to figure out what's going on, probably with a Wi-Fi in the background. And that's actually a bad way to run that command. And while it is just a tutorial, people will usually take this input and use it, where they copy and paste it from Stack Overflow or this tutorial website, or they just have this, oh, I saw child process exec, let's use it. It's actually very frowned upon, even in the Node.js docs, that they actually tell you, note, never pass unsanitized input. This is not the one to use, right? And granted, that config.Wi-Fi command looks like a constant that doesn't change, but let's just assume someone was able, through other layers of attack, to just inject something else. So exec actually, behind the scene, executes a shell with all globings and all I/O redirection, and your parameters that you want to add to your execution command is going to suffer if you're not sanitizing it correctly and someone is trying to inject something malicious. So it's a fail of, I think, maybe failing to educate the younger generation, because the Node.js and JavaScript is kind of young, even though it existed for a while. But this is something that we've mentioned PHP for a while, and PHP has been frowned upon for the same reasons. For the same reasons of, let's do things that just, a script, they are quick, they run, but it doesn't mean they are written in a good way. So I would like to see us do some examples on the web where we actually have these security notions taken into account. So with that said, yeah, it's a repeating theme for that. Can't take away with that thing with him. It's a good slogan. So let's make Node.js security great again. And I have a video prepared for you to just get you into that security mindset for hackers.
There's a new virus in the database.
What's happening?
It's replicating, eating up memory. What do I do?
Type cookie, you idiot. I'll head him off at the pass.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display. Die, dickweeds.
A rabbit is in the administration system.
Send a flu shot.
Rabbit, flu shot, someone talk.
All right, so I know it's funny. I hope you enjoyed it. That is how we used to hack system back in the 90s. It was all visual file systems like that. We were going in, and there were rabbits and Pac-Mans on the screen. It's actually funny. It's from a 95 hackers movie, kind of cult, kind of also laughed upon because of all of this weirdness that we were seeing before. So for me, security for Node.js started a while ago, about a year, when I was doing, I was working back then at HP, and we were doing a lot of threat modeling around Node.js. We also had this web application that was open and exposed to everyone on the internet. And this threat modeling cybersecurity team with HP, they were like, used to Java and .NET, and they have these really good protocols and libraries to talk about. But when you come to Node.js, you're like, how do I treat that from security perspective? It works completely different. And this is where I really dived into talking with them about how to do things right. And I learned myself and eventually wrote a book about it, which is very practical. There's not a lot of theory out of it. There's a lot of tips and tricks that we will use today of which best practices you can do to avoid issues, and also which libraries help you maintain those, the Node.js secure best practices thing. So then the first thing I want to start talking about is security that we can add through HTTP headers. And this one is one of those very low-hanging fruit where you can just implement it very quickly, understand what it does, and you can wave off some of the security issues that have been one of the top 10 for OWASP, for example. So I want to talk about three important ones that make the group. Yeah, not Destiny's Child, I'm sorry. I don't know how they got there. These guys. So the first one, strict transport security, is all about HTTPS. And that's what we're seeing today, especially with Let's Encrypt. So the web is being so important today that we can't anyway rely on HTTP. And this whole thing around the redirection that happens today, which this is the classic examples, where you have a bank site. Usually there's a lot of ads and advertisement stuff about the bank, and they have this login link that is HTTPS, and when you go to it, you're like, oh, it's HTTPS. I'm safe. But what happens is still that bank site is HTTP. So a man-in-the-middle attack could go in and do some SSL downgrading, so they would replace that HTTPS link maybe with their own HTTPS link. So actually, the fact that they were redirecting you to HTTPS link to begin with is vulnerable. And so that's what happens. And strict transport security is a header that you send from the server to the browser, and you tell him, well, the next time I visit you, for this and that duration of time, there's an expiration attribute that you can give it. Please do not do any redirect. Just load all of the resources under HTTPS, the CSS, the images, the JavaScript. Everything is going to be HTTPS. And there is no back ping route to the server to do like redirects, like you can do on the web with JavaScript, or you can do on the server side with HTTP. There is no. So that's one. The other one is X-frame options, which is all around iframes, where this clickjacking problem is, I'll tell you through a story. So I have this friend who's kind of heavy. I don't want to give his name. But Shlomi from Tel Aviv, I'm sorry. Didn't mean to do that. So he likes Nutella, and if he goes to this website, he's going to click on a free Nutella sample to just order it for him. And what happens behind the scene is I took an iframe for Twitter page, and I just layered it with CSS and other techniques behind the scenes, because I can load their website through iframes, theoretically. And when that happens, I can fool the guy, and this is clickjacking, where you press buttons on your websites that are coming up, and they can actually invoke clicks to iframes, other websites completely that are rendered behind the scenes. So the next time that those pop-ups are going to show, when you're watching whatever you're doing on the web, just think about maybe you are clicking that allow web camera to turn on and allow microphone to turn on, because there are techniques that are doing the exact same thing with just that, turning on your camera when you're clicking something which is like cancel, I don't want to install another Java update. We're good with the Java and PHP jokes today. I like it. All right, so content security policy, being the third one, is all about whitelisting trusted content, which basically means what if you could tell the browser which content to render and which not to? For example, let's say I don't want to render any inline JavaScript. What does that solve? Immediately, all of XSS attacks are going away, because you have just those script tags that we will see later on that people are adding in the forms. You have just told the browser, hey, don't render that, I don't trust it. Only render JavaScript that is coming from my domain, not from any other domain. And we'll talk about it later, because it can also cause problems. You have to know how your application works. Let's see. All right, so out of the tree, just like with Destiny's Child, there's a favorite one. Yeah, it's this one. It's my favorite. It's also a recent one and has been getting a lot of spec updates with regards to what the trust and content policy actually supports. So the way to do that in Node.js is using Helmet. Who has heard and used it? OK, very few people. It's good. We have this session. So let's see what's going on. And from now on, it's going to be a lot of technical and hands-on. So I'll try to keep it on pace. When you can't see stuff, just let me know, and I'll try to turn those fonts on. OK? So first things first. Do you know what this is? Is Guillermo here? No? He paid me to use Hyper.js app. It was like marketing for Zeit, do it, I'll pay you afterwards. All right, so I'm on the Node-Goat branch. It's me. I think it's the max. I'm on the Node-Goat project on my machine, starting this off, and should have a browser here somewhere. There we go. We're going to log in, and this is the sample application. It's nothing to show off here. It's just a sample one. Go to the Profile tab, and instead of your first name, usually when QA tests your application for security problems, they would go and do that classic, let's see, that classic script tag. I'll enlarge this as well a little bit for you guys. OK? Good. So what's happening here is Chrome is actually figuring out this is XSS and trying to stop you from doing this stuff. I don't know why, it's kind of cool for these presentations. But it didn't really solve the problem, because every page I visit, this XSS attack, which a developer, for example, at this page, wasn't output encoding or sanitizing it correctly, is happening. So I'm now susceptible to XSS attacks on this application. So the way to solve that would be, let's try to log out. Yeah, and go to my server config. Yeah, don't do any of the ES6 stuff here, so security guys. We're going to use Helmet. And I'm going to go after all of the others and just add mine. So for the front-end devs, or just in general, what we're doing here is we're using the Express framework and providing it a middleware that knows how to handle those browser requests. I think that should do it. Yeah, nothing. Interesting. Yeah, I have some other code I don't need here. Thank you. Let's do it again. All right, so we're logging in. Profile tab, this still happens. Let's see what happens here. So when I'm on the dashboard, now basically that script tag is not popping up. And we have basically, let's go up. We've basically told the Node.js app to send that content security policy HTTP header to the browser and tell it to just use, for the script source, all the script stuff that is JavaScript, just use the self. So it's only trusting the JavaScript that I'm sending from the browser, but it's not trusting all of that specifically crafted user input that gets inline JavaScript. And you can see it because if I'll turn on my, I'll enlarge this for you guys, so you can see it. But basically, Chrome understood it, and it's like, I refuse to execute it just because it violates the content security policy, right? So without now investing a lot of time with output encoding or input sanitization or stuff like that, which maybe you should do anyway, we can talk about that also later, but we have already mitigated those XSS attacks to a point. And the content security one, the content security policy one, is really my favorite because it extends not only to scripts, to the way forms and other embeds are happening in your HTML. So back to the slides. So Helmet, since you haven't heard a lot about it, you can just look at what's going on there. Basically, Helmet provides you XSS filtering and no-sniff, which are like IE specific, and Chrome. And it has the frame guard one, which is the X-frame options that we were talking about. And at the top, the HTTP strict transport security, and you can give it a max duration and set SSL. So you can apply all of those headers and some more just by using this middleware, and that's it. So NoSQL injections. Who's using MongoDB by a show of hands? Have used it? I would say some more by GitHub servers and stuff like that, but have you ever worried about NoSQL injections? Do you know they exist for MongoDB and other document-based? Right, let's see. So this is the classic one taken from SQL world, where it's like the Bobby drop tables. You just kind of mesh other strings with the queries that going unsanitized into the database, and of course it's going to, in this case, log in or do something else. And MongoDB queries to try and see if the username account matches a record if you're just using basically the MongoDB driver and not using anything else like ORMs or stuff like that. Then it's just user.find, you provide the username, which is from the request, and the password from the request, and that's it. And that has some issues. Right, I need this one. OK, so not sure if I can enlarge this screen, maybe a bit. So there is an endpoint here, which is an API login one. And what I'm basically doing is sending the wrong password to it. So if I still have the server up, it's telling me that it is incorrect. And this is OK, because I know this is the wrong one. So the API works. If I switch to the right one, which is this, and I send the same request, you can see that now I'm logged in. That benefits page and the logout button, so I'm already logged in. But what happens if you are not really strict looking at what you are sending and what you are receiving? And at this point, because this is specifically related to MongoDB and its nature of the operators that it has. So with MongoDB, it has those specific operators where you can say, well, something greater than, and that's like a regex or like a matching pattern. And basically what I'm doing here is I'm injecting those operators right into MongoDB to evaluate. And I'm basically saying, all right, so give me where usernames is greater than nothing and password is greater than nothing, and it's just going to catch the first one and give it to me back. So I'm logged in. If I go to the pretty page, you can see that it works. So I'm logged in again, right? Benefits and logout, and that just works. OK? So we've just hacked into the system using a MongoDB NoSQL injection. And it's, if you would search GitHub, it has that ability to search through code. And you would go and search for that user.find and username.username. That's what's going to happen. You're going to see a lot of results from GitHub, open source projects that are just using that. And sometimes you might even see just the username and not the password part. Doesn't mean it's extra secure. There are other like blind NoSQL injections that can happen. And just because of MongoDB working like that, and we'll see something related to Express in a second, this is a real vulnerability. So back to the slides. So why is this really happening, right? I mean, why is I'm sending a JSON request? Why is that getting translated into MongoDB? There's a reason for it. It's because Express doesn't have any way to parse your JSON body. It uses something else that is called body parser middleware to parse it. And if you'd open up any Node.js project, you're probably going to see this. It's the classic example where it's using body parser.json and body parser.url encoded, and it's just taking all of that JSON input and putting it as a JavaScript object. So it's now on your runtime, and that is why they are injected as actual operators to MongoDB. So I'm going to do an async thing for Node.js and try to go through this. Would you deposit your lifetime savings on a system written entirely in Node.js? Don't have that much lifetime savings, I don't know. I don't mind. I don't see why not. There's ups and downs for everything. And of course, you have to do things right. So you could write a poorly written system, very insecure, just as well in Java, in PHP, and in Python. It doesn't matter. There are a lot of stuff around it. I'm guessing it's related to security. So, and were you or a person you know affected by the Regex fall? No. It's a story I read about. All right. So that classic example where we see this is happening, right? You would see that route and controller being implemented, and you see user.find, username, request body, it's trusting the body input, and just giving you back the output. And we have seen how to, with a web tool, how to exploit it. But how would you actually fix that? What would be like the quickest fix that you would do to do it? Right, but we can do it in a very easy way as well. So, sessions here. There we go. This is my handle API login request, and it's right. And I need to validate API one. So this is the request being done behind the scenes. And the basic things would be, if we are actually knowing that username is a string, then why not casting it, right? This is before even going to frameworks and ORMs that help you do those stuff. Someone needs to contribute a NodeMon to this Node.js project. Yeah, it's one of you guys. Open source, you know. OK, let's see it now. So now sending this request would actually fail, right? I was sending the exact request, and it's failing. It's asking for the same username and password problem as we've seen before. OK? All right, so moving on. So best practices for security actually vary between different stacks. For example, would it be smart to validate and sanitize input before you validate the length of the string or the stream that you're getting? And it makes sense because for Node, CPU bound time is very important. So actually, kind of the first two are in a specific order. They're not just out there as bullets. So you would want to validate your length and type, cast it to whatever is expected, and the rest is just general security consideration that you should probably take regardless. That's just a small break, because I know security is like a hard thing. They're cute, right? All right, cool. RDOS. Regular expression DOS attacks has been quite interesting and happening all around JavaScript frameworks for a very long time. And I also mentioned one which just a few weeks ago received a couple of vulnerability updates, and it affected an entire ecosystem. I will show you later on. So when you think about regular expressions, by a show of hand, who has done regular expression at least once in his life? Oh my God. We're in such a bad situation now. This is really bad for us. I will show you why. Because regular expressions are like unicorns. You don't really know what's going on there, right? Or you know it, and then 5 minutes afterwards, what did they do? When you try to code review that, what is it? And don't do comments, right? Who has time for that? So any ideas what that is? You can just yell it. That's right, it's an IP address. It's a regular expression that matches IP address. And when you write it, yeah, and it works, you're like, hey. So it's working for me, right? I'm matching IP addresses now. Cool. Not so cool. I'll show you why. Let's match some song titles for our imaginary music app, OK? And the questions keep coming up. It's good. So I'll need your help with this a little bit. Internet be alive? Yes. OK, it's pretty large as well. All right, so we're matching song titles. Any volunteers to give me a song title in English, so we don't do UTF stuff here? Oh. It's nice. I like it. Oh, the TBD one, that's good. Nir, you're having quite an impact here regarding, cultural stuff with the TBD song. It's good. It's good for us. All right, so I'm going to work on this together with you guys. Basically, I'm going to use this example of a capturing group and then a matching token for any alphanumeric, and maybe there's a number there for, I don't know, some reason. Right. So it's working, but not for spaces. So I'm going to add any occurrences of that, and then a space. What were that song again? This one? Yeah. It doesn't work because I'm actually missing another quantifier to have repeating capturing groups, I believe. Hey. Everyone are now thinking, let's git commit it and send it there. It's working, right? I'm done with the Regex stuff for this sprint. That would be a very weird song. All right, here's where the sad part is when you get this user input from someone and they're trying to abuse it and they know like what's going on with Regex and they're just matching, giving that exclamation mark, you're suddenly going and getting this catastrophic backtracking. This doesn't look good and it's red. I'm not a front-end guy, but I know when it's red, it's not good. It's not good. All right, so I'm going to use the Regex debugger here to show you what's going on there and why we were all kind of stupid to write our own regexes. I'm sorry, I put myself in that boat as well. All right, so the way regexes work and what happens here, we were using greedy quantifiers, and basically the regex compiler computation infinite state machine thing is going through the string input that we got, and it has this matching criteria as the token, and it's trying to match them one by one. So it's matching and matching and matching through the tokens, through everything that we were having that plus at the end. And when it reaches a point where it doesn't recognize and has nothing to do with the exclamation mark, because there's no token that matches that one, it's doing a backtrack to maybe a shorter, less greedy quantifier to catch the rest. And obviously, as you can imagine, this happens for quite a while. So we've been doing like 80,000 steps, and that's just the browser or the debugger application here for Regex 101, just stopping that and warning you there's a backtracking catastrophe going on there. Backtracking catastrophe, that just sounds bad. All right, so this is actually a problem for Node.js as well. It's not on the browser or just a general one. I have saved it here. Not this one. Not this one as well. Oh, there we go. All right, so I don't know, you can see that one? I'll try to, it's OK? All right. I don't know how Hyper.js is stable or not, so I just want to run it. Just kidding. So basically, I've put a time, I've prepended a time command for my node eval1, and you can see it's the same regex. and basically the same input. And when I run it, it runs for hours. And I don't know how many times. I actually never waited for it to finish, because it could happen like 100 years, or say 1,000 years, like 1,000,000 years, like 1,000,000,000 years. So I didn't wait. You get a point. All right. So it's important to understand this, because when you guys are writing regex on your Node side, you are basically, because this is Node and this is not a multi-threading app, you're basically blocking that event loop, because this is CPU-bound operation. Node doesn't know how to take this regex problem and put it on a worker thread or something else. You are doing that as part of your JavaScript call stack, and now everything is waiting for this to finish. So if you have this problem on your Node.js project, you might be susceptible to the same regular expression DOS attacks that has been happening for other JavaScript frameworks. All right, so back to the presentation. You guys having fun with the hands-on stuff? All right, so we were matching it, and when it kind of blew on us, it's like Brittany is like, oh, man, I knew that would happen to you. All right, so regular expression DOS attacks, we talked about some of it, but don't think that a really large or a weird or a complex regex attack string can be a problem. It can also happen for very short regex expressions. So that's why I'm going to show you that regex is a real problem. I put the rest, like the older ones, except MS, a while ago. And then MS, that library, which we can go in a second, and I will show you that it has like 3 million downloads a month or something like that, has had the same problem, which was susceptible to the exact same problem, regular expressions that MS is doing. And the rest, you're pretty familiar with them as well, right? Marked, Uglify, Moment. They're pretty popular NPM repositories around the Node.js ecosystem. So what are some regex best practices for you guys? I have this paper that you guys need to read. It's on how to write regular expressions. I'm going to give it to you guys. Just pass it along. And this is, I already talked with all of your team managers. Do you want to take it? So basically, you have to read it through before you implement another regex. And I'm just kidding. I know no one will read it, so we'll do this. So because I know none of you will read it because you're lazy people, developers are so lazy. So here's the first regex, best practice. Right? Don't write it. Why write it? And the next one is my favorite. You guys would love it. There we go. Can I continue, or did you guys get it? All right. So the real one is basically if you need to validate some kind of expressions that they are going on and they're OK, there's this validator Node.js library that we were talking about before. And you can use it. It's pretty popular. And the thing is, you're now offloading the risk to someone else. And if you have paid attention before in the previous slides, it was also problematic with some of the regexes that it was using. But at least someone else is trying to attack and break this one. And there's a lot of other people also trying to fix it. So it's probably safer. You try to offload this thing. And it has all of these regex patterns that are pretty common around the industry, like is it, I don't know, base64, is it date, is it IPv4, is it email? So you guys don't have to write all of those things and maybe mess it up, okay? Because we don't really know. For situations where I get it that sometimes your regex pattern is, I would say, very custom to what you have, and there's nothing else to do about it. There's this library called SafeRegex, where if you're using it, it's going to try and detect whether your regex that you've put it as an input string or just a regex expression in JavaScript is OK or not. So I hope you're not giving the regex expression from an input string from the user, because that would be bad. But that's an example of how that would work if you had to test it. All right, so moving on to The other thing which I really like and kind of relates to secure dependencies, and that is security ops. Everyone are doing CI/CD. I really hope you're doing tests. But how would you know around the Node.js ecosystem, which has more modules, mass, than a black hole, how would you know that they are safe, right? Because when you're developing Node.js applications, that's probably the basic question that you would have to ask yourself when you're going into production and having this security mindset along with all other questions. This is one of them. Because you're now using open source modules that someone else wrote. Maybe one of you guys here wrote it. But we don't know if it's safe, if it's OK, if someone checked it. So I want to introduce you to a case and this tool, which you'll see through the example. I'm actually going to run it again to just give you the context for it. So I'm logged in, and I have this memos checkbox, text area, that maybe I want to leave a memo for someone. So it would be something like this. Oh, yeah. Dry runs. I'm going to remove this one. Yeah, we're still stuck on that one as well. All right, so hello JSHeroes, and then comes a request from requirements, product, whatever, and they're like, hey, maybe do it markdown style so it can be a little bit prettier. So you can do stuff like this would be a title maybe, right? But it doesn't work. So you go around and you ask, well, it's probably a JavaScript library to do it, right? And marked is pretty popular with doing that. So I have it already installed. And I'll go and we had it before. I'll just add it again. Just adding it here. Can just put it before of my routes, which would be so big. This. Sometimes you don't really remember the syntax for it, so this is useful. It's running npm home marked, and I should bring it up here. Or it's not. I don't know what's going on there. Is it trying to, oh, I have it probably on a different window. Weird. OK, so this one. Oh, it's just the internet completely died in general, I guess. All right, so let's try it. I guess I remember some of it. Yes, it was set options, and then I wanted to give it a special one, which I remember to be sanitized true. And that means it's taking extra caution when it's doing those sanitization on the HTML input that you're giving it. And of course, I have to put it as a local variable so I can use it in the memos view. All right, let's see if I got this stuff working. Yeah, no internet for us, but we don't need it. Oh. So what I actually want to do is, since we're testing it on a different library, I want to go ahead and show you a situation where we actually didn't have that content security policy right in, right? Because otherwise, can I not run it? Or no, it's OK. I don't need it for now. OK. Yeah, so we still have that. I'm gonna remove this for a second. Hey, worked. Amazing, the world of JavaScript. Right? I guess we're in a good ecosystem. So far so good, right? But what happens if someone gives you a link? I hope this is the right markdown syntax. Yep, and that would basically, if internet were here, would have worked. But the problem there is, what happens if we try to inject it with the same script alert, right? So I'm going to try doing that. And then JavaScript alert 1. It doesn't really work for me, so I'm kind of frustrated hackers. You know those? They kind of have those hoodies, stay at home all day, try to hack other stuff. So I'm going to give it, it's a bit challenging, and I'm going to give it another try. And I'm going to try and use something which is HTML entities to try and trick it and see if it catches that one. So if I remember correctly, what I'm trying to do here is, this is the HTML entity that corresponds with a colon. And the same for closing the brackets. And it still doesn't work, so it's catching up pretty well on the sanitizer. But browser, they have this thing where they're trying to be really nice all the time. It's like the nicest software. Did you ever try to give it a broken HTML with broken divs? What happens? It fixes it. Because it's so nice, it's trying to please you. It's like, hey, you're front-end guys. I'm going to work for you. Right? You guys can see it? I don't know. All right, so what I'm going to do is try to fool it and give it a valid character for JavaScript that's going to evaluate later. And basically, I know this works, so I'll just show you. That we were able to circumvent the sanitization that happens on marked library. And this is one of the reasons that it was vulnerable before. And I don't know if we still have internet. GitHub marked. Oh, wait, it's working. I got it. Yeah, just turn up. Thank you. So we've all been using it. It's pretty simple. It's pretty popular as well. Right? In theory, if we hadn't put any security mechanism or testing around this one, all of those 3 million downloads people, in theory, were getting the same infected version or vulnerable version, were susceptible to the same problem, assuming they didn't encode and decode it, the other way, of just passing on that input and doing like we did. And probably that's the majority of people, right? So how do we deal with these problems? And by the way, I removed the helmet content security policy because if we had it, we were actually being protected from it, and you wouldn't see that demo running. Right? So that's another reason why you have security in layers. So going over to, where are my slides? All right, so what is Sneak? So Sneak is a relatively new tool for security. And what it does is, wait on the slides as well for you guys. So what it does is, it's a tool and a platform. They are very much open source. So the researchers, team behind it, security researchers, are maintaining this CVE, the Common Vulnerability Database, for all of the known issues around NPM packages, or they have actually expanded to Ruby, and they're doing Java now, I think. And front-end, and all of this, of course, goes to front-end and back-end developers regardless. So what it does is, when you install it, and use it, it's going to check your package JSON for the dependencies that you want to rely on. and it's going to recurse all of your node modules directory as well, and check and match those to what you have. And then it's going and looking at its open source database that anyone can go in and see all of those vulnerabilities and the patches for them, and tell you if it's vulnerable or not. They're not the newest tool that was doing it. NSP, the Node Security Project, was doing it as well, but it was kind of sleepy, and during that non-security mindset that was happening for developers, it didn't really get any attention. When these guys came in, they put a whole platform around it, and they're pretty much working a lot together. So I want to show you how that works. So if I were just, we need internet, so I hope this works, actually. So basically, just by running sneak test, I just installed it, the npm install, -g or yarn, whatever is your favorite. It's going to check what I have installed. I thought we had a problem in Israel where we're commuting to work on camels, but I don't know. Right, so until that works, have a screenshot for it just in case. So as you can see, it found, when I ran it, it found some dependency, some vulnerabilities in my packages. And it's going to tell you if it's a high or a low one by standards of industry that they rate. And you have that, there's a regular expression in one of the dependencies. The below one is actually pretty interesting, the uglify.js, which you would say, uglify.js, I don't know, it's like a build tool. I run it through Webpack, Gulp, Grunt, whatever. So I don't really care, and it's okay. It's okay if you don't care about it, if it's just minifying your stuff on the server, before you serve it. But you should know about it. And the most interesting thing that happens here is, I can move my mouse or point to this one. But basically, it's not just about your dependencies, right? There is the notion of transient dependencies that I'm getting from other dependencies. So I'm actually trusting another dependency and its dependencies. So it can show you that through Sneak and Mocha and Glob and Minimatch, that's the dependency tree of why Minimatch and how you got it and why it's vulnerable for you. So you can go ahead and figure out, hey, maybe I want to upgrade Minimatch for a new version, which is possible. Maybe I just want to patch that one, which the tool also provides. Maybe you just want to switch from, I don't know, Glob to something else. Maybe you just want to wait it out and, all right, take the risk. You're vulnerable. At least you know about it. Right, so this isn't really working, and I don't have previous history. But if I did, you would basically see that on this project, it would have find marked, and MS, which this project still uses, and it's all over the place. And basically, it would just spawn a lot of security vulnerabilities. Right, so back to the slides. All right, so, and this is a true story. When we do CI/CD team in my team, I'm doing the same. I'm running the tests on every PR and every commit in the office, and we've added Sneak as well. So when developers are now adding suddenly marked for some feature or some other vulnerable library, the PR, the input that you have there is going to tell you, hey, you have a vulnerability in the package that you just introduced. This is really cool because you can use it in open source projects as well, with all the GitHub integrations. So you're not just getting Travis and coveralls updates. You're now knowing if your project is up to date with dependencies, if your project is vulnerable or not. All right, so to conclude this session, I really want to leave you with this because I know it was a lot of topics, but just take those bullets. And HTTP headers can help a lot. NoSQL injections happen. So this is all about really, the NoSQL injection was just a story to tell you to sanitize your input and stuff like that. Avoid your own regex as well as you can. And Sneak or Yarn to secure your NPM dependencies as well. That's it.